Hi, everybody. We're hoping you have a good day whenever you're watching us. We are students from the University of Colima of the Faculty of Chemical Sciences, and we are studying the career of chemical pharmaceutical biologist. We also are members of the team number 10, and today we are exposing the results of our integrative project.
Introduction. The solubility constant, or KSB, is the constant of equilibrium that occurs between solids and the ions of a saturated solution. The KSB of a solution can be determined using Gibbs free energy, or known as delta G. And at two distinct temperatures, we can observe the values of standard enthalpy, delta H, and standard entropy, delta S. Gibbs free energy is the amount of no expansion work that can be extracted from a closed system. Entropy and enthalpy, instead, interact with temperature to predict the spontaneous process of a chemical reaction. And so, the solubility product constant is important in all types of processes that imply a change of state, which allows us to determine what conditions have certain effects on certain matters. Using this experiment allows us to integrate aspects of analytical chemistry, experimental design, physical chemistry, and the theme of the investigation was based on the determination of the solution constant by means of experimental and theoretical data. This was done using physics formulas to obtain the enthalpy and entropy.
The objectives. We raised the objective. Three of them were based on the handling of materials and the requirements of what the teachers want us to work at the project, while the other three objects were aimed at determining the KSP, standard enthalpy, and standard entropy of calcium hydroxide. Analyze the change that occurred in the solution before and after going through the colorimetric reactions. Calculate the analyzed values to be used and the nitration of the acid used and carried out the nitration of the hydrochloric acid prepared at 0.05 molar to check the good preparation of the titration. Methodology. Within the methodological proceed that described that in the relation of the project, three of them were covered. The first one is the determination of calcium hydroxide at room temperature, where we filter the sample at preparatory liquids of calcium hydroxide in a milliliter flask, diluting 10 milliliters of the filtered sample in 15 milliliters of distilled water. Then add the indicator promethyl blue and treat the solution with 0.05 molar hydrochloric acid until the sample changes color. The second is the hydrochloric acid treatment of 0.05 molar that first calculate the amount of calcium carbonate to use. Then dry it in a driving oven for 1 at 2 hours. Then we remove the sample and allow to cool for 30 minutes in a desiccator. Then prepare the three liquids by 0.015 grams of sample within 10 milliliters of distilled water and indicator methyl orange. Finally, treat the acid solution with hydrochloric acid at 0.05 molar until it turns pink and heat the sample until it starts to boil. If the solution changes to a yellow, the color solution is treated again until it turns pink. The last one is the preparation of the hydrochloric acid solution at 0.05 molar. Then we calculate the milliliters of concentration acid that we were used to prepare the 0.05 molar hydrochloric acid solution. So we add 5 milliliters of distilled water to a volumetric flask. and then we add 4.222 milliliters of commercial hydrochloric acid with concentration of 13 to 38 to 36% and a density of 1.15 grains per milliliter. Finally, make the solution up to 1,000 milliliters.
According to the results observed in the tables and the analysis of data, the KSB is calculated at 30 degrees. The KSB calculated at 30 degrees is similar to the ones found by other teams. In contrast, when it comes to results about Gibbs free energy, our results are below the average found by other teams. As can be observed in the results, there is a connection between the results of KSP and Gibbs free energy. The results are in line with the expected results according to the theoretical mark. Utilizing these results obtained and the KSP obtained of the other teams, it was determined that the standard enthalpy at 64 degrees would be 329,980.32 joules per mole. Using this result, it can be determined that the KSP at 64 degrees would be 3.56 repeating 10 to the power of negative 10. With the KSP, we were able to determine that the variations of Gibbs free energy was 25,497.81 joules per mole. Finally, with the KSP, we calculated that the margin of error in this experiment, which gave us a value of 18.23%, was based on the absolute error of 2.0308 to the power of negative 4.
Am I being listened? I don't know if my microphone is working. Could somebody please tell me? ¿Se escucha mi micrófono?
Sí, sí, vamos a tener que volver a grabarlo de nuevo porque no se puede
No,
rectificar.
it's okay, it's okay. I said it in English. Well, as a conclusion, we achieved our goal, which was to calculate the enthalpy variation, and also the Gibbs free energy and the dissolution constant, which is the KPS. And well, we obtained it as a result that the KPS heated or calculated at 30 Celsius degrees is a value of 2.7568. This multiplied by 10. Also, the enthalpy has a value of less 305284.8 G over mole, and also, well, the Gibbs or the variation, which is delta G, which means the delta free Gibbs energy, is a value of 25.4978 kg per mole. In the same way, the results were placed in graphs and tables where the relationship between the concentration of the KPS and the Gibbs free energy were inversely proportional to the results obtained. And well, these results were obtained through experimental data. Also, as part of the practice, we evaluated hydrochloric acid at 0.50 molar. And well, to verify the correct preparation of the acid, and also other additional objectives that were raised were the application of the correct use of the laboratory equipment provided, and which was, for example, the burettes, the flags, and other stuff. We were testing our instrumentation ability in the laboratory to perform the experimental part properly and well. During the assessment to obtain the molar concentration of the calcium hydroxide, the change we observed occurred during the experiment when we added the indicators. These indicators caused a color variation that was very involved or was caused because the pH of the solution. And as a final goal, we were able to perform all the stages of this experiment while we were implementing our knowledge of the various assignments that supported us, such as psychochemistry, experimental design, analytic chemistry, and English. And in each aspect of the experiment, we applied them as they were required. And that's our conclusion. We are very thank you to watch our video, and we hope you have a good day and see you later.